This video is going to act as a supplement to the one that just came before, where I introduced this idea of graphing trig functions, and specifically we spent a lot of time focusing on sine of x. And so I'm just going to use those tools that we developed in the last video, where we introduced this idea of period and amplitude and phase shift and vertical shift and stuff like that, to talk about the graph of cosine of x. So you'll notice that the very first thing I do when I'm just drawing like a naked cosine graph, right? There's nothing in front of it, nothing inside of it, just cosine of x, is I'm going to plot the typical period, right, which is 0 to 2 pi. So that's how I know that's how many marks I'm going to get, right? So 3 pi over 2. And that cosine, I know the range of cosine goes from 1 to -1. Okay, and so remember that on our old friend, the unit circle here, on the unit circle, cosine has a whole bunch of values, but the normal period starts at 0. We have pi over 2, we have pi, 3 pi over 2, and then 2 pi, and then we start repeating values. So it's just important to remember that, we can make a table of values, which is always a good idea to do. But because we did that in the last video, I'm going to do a little bit more of a streamlined approach, where I'm just going to say I know that at 0 degrees or 0 radians, we're at the point 1, 0. And I know cosine has a value of 1. So I go ahead and put that point right up there. Okay, maybe I should leave my axis. This is theta, or I guess for us, we're using x. So maybe I should use x, and then this is y, my output. Okay, so if we put in 0, we get out 1. Okay, now how about pi over 2? What's cosine? Well, cosine is equal to 0, and then at pi, right, cosine is -1. The x value is -1. We're back to 0, back to 2 pi, and we start repeating our pattern. So, just kind of very lightly going through and sketching this, and it kind of just repeats on forever, right? And so what are some things we notice here? So, the amplitude is 1, because if we imagine that there's what we call like a center line here, if you take, one way of thinking about it is you take the distance from the very top all the way to the very bottom, you get 2. So if you cut it in half, the amplitude is the height of the wave. That's going to be 1, and kind of that midpoint is what we call the center line. So the amplitude is 1. There's no horizontal shift. There's no phase shift, because this is just the regular cosine graph. There's no vertical shift, because again, this is just the regular cosine graph. Let's see, what else? What's the period? Well, the period is exactly the same as it was for sine. It's 2 pi divided by the absolute value of b. But because our b term here is just the coefficient of x and it's 1, we're just going to get that the period is 2 pi, which is evident in our drawing. Okay, so now let's try and do a modified one. Let's just do y is equal to -2 cosine of, let's do 2x minus pi plus 1. Okay, so what's the strategy? Okay, what's the strategy here? The strategy is going to be to figure out all the pieces and then try sketching it. Okay, so maybe I would say, let's start by sketching maybe -2 cosine of x, right? So just a regular cosine graph that has a slightly different amplitude. So, here's my first attempt at maybe what this thing might look like. So here's my graph. Now, I know my amplitude here is 2, because remember, the amplitude is the absolute value of this coefficient here, right? Remember, if cosine, right, cosine goes from -1 to 1, then when I multiply it by -2, it's going to go from, if I multiply this by -2, I'm going to get -2. And if I multiply this by -2, I'm going to get +2. It increases the possible y values that I'm going to get. So that means that I'm going to draw my graph instead as, I'm going to put some marks on it, right? And so here's 2 and here's -2. And then I know, again, that the period of my graph, now if I'm just graphing cosine of x, right, the period's 2 pi. Let's just pretend that I don't know what the period's going to be of this graph quite yet. I can still do myself a favor and make my 4 tick marks, right? Because the original one, right, the original unit circle goes from 0 to 2 pi, and it cuts it up like this, like so. Right, this is the original one, but it's always 4 tick marks. Why is it always 4 tick marks? Because the unit circle has four pit stops. As 1, 2, 3, 4, right? It's got four ticks before you get back to the start. So if I were just sketching -2 cosine, the negative means I'm going to start down at -2. You can try it. If you put in 0 for x, I'm going to get cosine of 0 degrees, which is 1. Times -2 gives me -2. So the negative, remember, flips our graph, starts us here, and then everything else should be the same. We're going to be at 0 here, at pi, we're up here, at 3 pi over 2, we're here, and 2 pi, we're down here. Now this is the -2 cosine of x graph. Okay, so what about, actually doing this graph in its entirety? Okay, well, let's try it. Let's kind of look at this graph and figure out some things about it. We already know the amplitude is going to be 2. Okay, there's a vertical shift. A vertical shift of what? That means up and down. We're going where? Well, we're taking the entire graph. We're bumping it up 1 unit. Okay, so if I account for this, the vertical shift of 1, I already know that my new graph is going to start here. And it's going to have some different points of intersection, right? All these points get shifted up 1. Kind of something like this, right? So every single one of these points, we went from 0, we raised it to 1. We went from 2, we went up to 3. We went from 0, we raised it up to 1. We went from -2 and we raise it up to -1, right? So we've shifted this graph up 1 unit. That's what that graph would look like. So the green graph is, y is equal to -2 cosine of x plus 1. Okay, so we're slowly taking little bites of this. Now, what if I want to talk about the period? Well, remember this graph is not in standard form yet. Remember that standard form, we have to factor out that 2 on the inside to get, something that looks like this. We're going to get 2 multiplied by some stuff and then plus 1. So what goes inside that parentheses? Well, if I divide a 2 by everything, I'm going to be left with an x here. And what happens when I divide pi by 2? Well, I'm just going to get a pi over 2. And you can verify this is the same thing by multiplying the 2 back in. Now, why do we have to do this? Because as I mentioned, if from pre-calculus 1, this is the standard form of any function's transformations. And for us, we get that our b term here is 2. So this gives us that our period is actually 2 pi divided by the absolute value of 2, which is just pi. So that means that our unit circle that we're basing this on, okay, how long does it take to get around? Well, it doesn't take 2 pi seconds to get around, right? If we start at 0, now it's only going to take pi seconds to get around, which means to get halfway is pi over 2, to get half of that is pi over 4, to get 3/4 of the way is going to be 3 pi over 4, right? And you can think about that because if, going here is 1 pi over 4, then this is 2 pi, right? 2 pi over 4s. To get here is 3 pi over 4s, and then to complete our journey would be 4 pi over 4s, which is pi. Okay. So what does that mean for our graph? Well, that means that all we need to do is we just need to relabel this to indicate the fact that our graph is actually moving faster. So this part right here is pi. This right here is pi over 2. This is pi over 4, right? And so on. And then this is 3 pi over 4. So this indicates that our period is pi radians or pi seconds, or however you want to view it if we were talking about time right? And this is a sound wave. How long is it going to take to repeat itself? It's going to take pi seconds. Great. So roughly 3.14159265 seconds. So that, this, what I have now in green, let me modify this graph a little bit, and I'm going to erase this unit circle just to make me some space. So this green graph, with the fact that I've labeled it as I have, is actually -2 cosine of 2x plus 1, right? It has a period of pi, has an amplitude of 2. It experienced a flip, right? A flip over the x-axis courtesy of this negative sign, and a vertical shift of 1. So we're almost done. The only thing we haven't taken into account is the horizontal shift or the phase shift, and by looking at it in standard form, right, this form right here, we can clearly see that we're going to experience a phase shift. We're going to experience a phase shift to the right, pi over 2 units or seconds or however you want to say it. It's also okay if you wrote, to the right pi over 2, or you just wrote plus pi over 2 units. So how do I sketch it? What's the final product going to look like? I'm going to erase this brown graph now that we have kind of like the idea of it. And we're going to leave everything else labeled. All right, cool. And so, oops, I erased this. So if we're shifting all the points to the right by pi over 2 units, that means that this point is going to end up over here. This point's going to end up over here. This point's going to end up over here, right? And so on and so forth. And so our graph, maybe I'll use, what color should I use? I guess I can just use yellow. So our graph is going to now look something like this. Okay, so there is our new graph. And this graph right here in yellow is the finished product. This is -2 cosine of 2x minus pi plus 1. This is the graph that we started with, and that is what we were tasked with sketching. So you notice, you can just build it bit by bit and make small little adjustments. I don't recommend going for all of it at once. Just go bit by bit and build pieces until you eventually reach the final product. Now, why are we doing this? Why are we sketching these graphs? Because next week what we're going to really focus on is how to really use these in a real world application. And trig functions are probably some of the most used functions to describe natural phenomena in the world. If you want to talk about modeling the stock market goes up, stock market goes down. You want to talk about temperature goes up during midday, it goes down during the night. It goes up during midday, it goes down like this. You want to talk about sound waves. Sound waves oscillate, go up and down like this. You want to talk about a spring going back and forth. Okay, it experiences motion like this. You want to talk about a shock absorber in your car bouncing up and down. Looks like this. You want to talk about noise-canceling headphones that take a sound wave that looks like this and play back the opposite sound wave at the same time to create almost an entirely canceled sound so you don't hear anything. It's all trigonometry. It's all these sines and cosine functions. So super important stuff. That's where we're headed. So I hope you enjoyed this extra video talking about, how to sketch the cosine graph. And in the next one, I'm going to briefly talk about the tangent, cosecant, secant graphs. But in my opinion, for the focus of this class, and to be honest, in most of my mathematical career, I never really cared much about those graphs. So it's probably going to be a relatively short video, but